This problem is dealing with cell potential and free energy. Free energy change, or delta G naught, is related to the cell potential, E naught, by the equation delta G naught is equal to negative NF E naught, where N is the number of moles of electrons transferred, and F is a constant, in this case 96,500 coulombs per mole of electrons. Part A is asking us to calculate the standard free energy change at 25 degrees Celsius for this equation here. So it's asking us to calculate delta G naught. First thing we need to do is we need to break down this reaction into the two half reactions, the oxidation and reduction reaction. Once we have those half reactions, we can go ahead and find the standard potential of the reactions. In this case, we have 0.447 for this one here, and positive 2.372 volts here. Cell potential for the reaction is the sum of the cell potential for the redox reaction and the cell potential for the oxidation reaction. Combining these two numbers, we get the cell potential for this reaction here. In this case, it's 1.925 volts, which is given here. The last thing that we need to figure out is the value of N. In this case, N is 2 moles of electrons transferred during the reaction. We go ahead and plug in all the information that we've gathered here, and the answer for delta G naught in this case is negative 3.71 joules. For part B, we are asked to calculate the standard cell potential at 25 degrees Celsius for the reaction, which is given here. In order to do so, we need to use the following equation. The equation that we're going to use is delta G naught is equal to delta H naught minus T delta S naught. Temperature in this case needs to be in Kelvin, so we get the 25 degrees Celsius and convert that into Kelvin. Once we have all the information, which we have here, delta H naught and delta S naught, we plug it into the equation to get delta G naught is equal to negative 673,404.85 joules. Once we have solved for delta G naught, we can use that in the equation that is given here. We have delta G naught is equal to negative NF E naught. One missing piece of information that we need would be N, which is the number of moles of electrons transferred during the reaction. The way that we go about doing that is we break this equation into two half reactions, and that will allow us to see that there are 2 moles of electrons transferred during the reaction. We go ahead and use this equation up here. We solve for the cell potential, E naught. We plug in all the data that we have, and our answer in this case would be 3.49 volts.